Hello, and we are back. We're looking at geometric series today. Remember that a series is something where we're adding up something, and geometric means that to get to the next term, you multiply. So here, think about 6 times what is 12? 12 times what is 24? Should be pretty straightforward, times 2. This is called R. You can get a quick review on this by looking at my geometric series video. So we know that R is 2, we know that the first term, or u sub 1, is 6, okay? And we want to know the sum, because it's a series, all right? That means adding up the terms of the sequence. So the sum of a geometric series is given by the formula u sub 1 times the quantity R, that's this number here, to the n, that whole thing minus 1 all over R minus 1. Okay? So we're going to plug in what we know. We're looking for the sum. This is n here, is 12. So we just plug in those numbers. It's going to be 6 times the quantity 2 to the 12 minus 1 all over 2 minus 1. Now geometric series get really big really quickly. Just so you know, the numbers get nice and large. So you have to figure out what 2 to the 12th is and then subtract 1. So this ends up being 6 times 4096 minus 1 all over 1, which simplifies to 24,570 in this case. All right, nice big number. That's the end of the box. Okay, so you just plug it into this formula. Now, if you're in IB Math Studies, you're given this formula, no big deal. Don't have to memorize it, okay? So I think it's your turn to try one. You're going to try the sum of the first 12 terms of this series right here. Go ahead and pause the video, give it a shot, okay? Pause it now. Okay, and we're back. The sum of the first 12 terms of this geometric series, R is 3, u sub 1 is 2, n is 12. Plug it into the formula, you should get 531,440. So now, but of course, the geometric series, a lot of times R is a fraction. That's what you'll see more often, and I know that that gives a lot of students trouble. I just want to show a quick example of that and have a practice of that. So if we have the first 7 terms of this, so if you think about it, what is R here? 36 times what is 6? 6 times what is 1? Yeah, it's 1/6, okay? So that's R. And then again, u sub 1 is 36. And we're looking for the 7 terms, so the first 7 terms, so n is 7. Okay, so the sum of the first 7 is going to be 36 times 1/6 to the 7th power minus 1 all over 1/6 minus 1. So I would recommend in your calculator actually plugging this in. This is going to be some ugly decimal. But you plug this in first, minus 1. I would actually divide by parentheses, 1 divided by 6. And then minus 1 in parentheses, and then multiply it by 36 is how I would do it. Oops, let's cancel that. So anyway, you plug it into your calculator, and you end up getting 43.19984568. Now I know in IB Math Studies we want 3 significant figures, so that would be 43.2, because this tells me to round this up. All right, and then a lot of times with this, you want to make sure this makes sense. If you think about it, 36 plus 6 is 42, plus 1 is 43. Is it really just going to be a little bit more than that? Well, plus a 6th. A 6th is not quite 0.2, and then plus a 36th. So yeah, that does make sense. That all the other terms here, even on to infinity, add up to just very, very little amount. So that does make sense. Okay, so you want to check the validity of your answer as well. Always, that's a good idea to do. Okay, so go ahead and try one of your own. The sum of the first 9 terms in this case, 200 plus 50 plus 12.5 plus ... This is a geometric series. Go ahead and pause the video and give it a shot. Pause it now. Okay, so I plugged everything in here, and I got this ugly decimal from my calculator. I'm going to round that up to 267, because that's 3 significant figures. If you round differently depending on your teacher, that is fine as well. One quick note about this is that with these geometric series, a lot of times you can get really close to the correct answer. You can check your work just by adding the first, first 4, 5, 6 terms. 200 plus 50 is 250, plus 12.5 is 262.5, right? You can take the next one, and then the next one, and then the next one. You'll get closer and closer to this. So obviously it's a good way to check your work. I would assume that your teacher would want to see the more advanced stuff going on there. It does lead to what's called infinite geometric series as well, which we're not going to talk about in this video. But there's a great video by V. Hart called Infinity Elephants, and here's the URL. But in general, if you had a square, you can think of it like this. Let's say we had a square that's 1. This is 1 meter by 1 meter, 1 something by 1 something. And I took half of that, and I colored it in. And then I took half of what was left, and I colored it in. I took half of what was left of that, and I colored it in. And I took half of what was left of that, and I colored it in. And I took half of what was left of that. And I kept coloring in just half. You can see that I'm getting closer and closer to coloring in the whole thing. And if I do it an infinite number of times, I'll get way in there, and I'll pretty much color in the whole thing. In other words, if I color in first a half, and then this part is really just a fourth, and then this part right here is really just an eighth, it's a half of what's left, and this part right here is really just a half of what's left there. So that's a 16th, and then a 32nd, and then a 64th, on and on and on. That, obviously, just by looking at it, that's going to equal 1. Okay? So it comes back to the formula, because if the sum of an infinite, if we're talking about this one, right, to get to the next thing, r equals 1/2, right, but u sub 1 is 1/2, so it'd be 1/2 times r, 1/2 times that's our first term, and it's our r. So it's going to be 1/2 times 1/2 to the infinity minus 1 all over 1/2 minus 1. Now 1/2 to the infinity is 0, because this is obviously approaching 0. So this is 0. So really it's just 1/2 times negative 1/2 over negative 1/2. That's just 1. Which is kind of cool if you think about it. If you're, nerdy and mathy like that. So again, go ahead and watch this video. Very interesting about infinite sequences and series. Just kind of fun. It's under 5 minutes. I hope you learned a thing or two, and we will catch you next time. Toodles.